Imagine a journey not by a rocket but an elevator that takes you straight into space. This is the basic concept of a space elevator, a seemingly fantastical idea that might just revolutionize space travel as we know it. So, how would it work? Picture a tether, like an unimaginably long cable, anchored to the Earth's surface and extending upwards, far beyond our atmosphere, into space. At the end of this tether, a counterweight keeps it taut, providing the stability needed for this celestial elevator. Vehicles, or climbers, would then ascend this tether, essentially riding it all the way into space. It's not just about the novelty though. Space elevators could offer significant advantages over traditional rocket launches. They could be more cost-effective, produce less pollution, and provide a more consistent, reliable access to space. Sounds like a science fiction dream, doesn't it? But the idea of space elevators has been around for more than a century. The space elevator concept isn't new, with roots dating back to the late 19th century. This fascinating idea has been evolving for over a century, with early visionaries like Konstantin Tsiolkovsky leading the charge. Imagine, a tower reaching from Earth to geostationary orbit. Sounds like a dream, right? Well, it was Tsiolkovsky's dream, inspired by the Eiffel Tower in Paris. As we moved into the 20th century, the concept didn't just stay a dream. It grew, matured, and adapted to the changing times. Scientists and engineers began to introduce more advanced concepts, incorporating cutting-edge technology. The introduction of materials like carbon nanotubes with their exceptional strength and lightness brought a new dimension to the space elevator concept. It's been a journey of imagination, innovation, and sheer determination. From the vision of one man to the pursuit of many, the space elevator has come a long way. While the concept has evolved, the challenge remains: how to make the idea a reality. Turning the space elevator concept into reality has been a daunting task, but not for lack of trying. Companies and researchers worldwide have been grappling with this challenge, with Japan's Obayashi Corporation taking a notable lead. They've boldly set a target to have a space elevator in operation by the year 2050. However, the road to achieving this feat is fraught with obstacles. A primary concern is the strength of the tether material. It's a Herculean task to find a material robust enough to withstand the immense forces, yet light enough to be feasible. Next, we encounter the minefield of space debris. Our planet's orbit is a cosmic shooting gallery, filled with millions of pieces of rapidly moving debris. Any space elevator would need to withstand or avoid these potential projectiles. And then, there's the elephant in the room, the astronomical cost. Building a space elevator would require a financial commitment that dwarfs any current space project. Despite the challenges, the allure of a space elevator remains. So, what does the future hold for space elevators? As we embark on a new era of space travel and exploration, the potential impact of a space elevator is nothing short of revolutionary. Imagine a world where we could ascend into the cosmos, not with a rocket, but with an elevator ride. The prospect is truly tantalizing. The feasibility of space elevators hinges on ongoing research into new materials and technologies. Carbon nanotubes, graphene ribbons, and other advanced materials are showing promise, but we're still in the early stages of understanding their potential. The timeline for a fully functional space elevator is still uncertain. While some optimists hope to see one in the next few decades, others caution that we might be a century or more away from this dream becoming a reality. While the space elevator remains in the realm of science fiction today, who knows what tomorrow might bring?